This video, we will look at an endothermic reaction demonstration. Just as a review, an endothermic reaction is a reaction where energy is transferred from the surroundings to the system. The reaction we're going to look at in this video is the reaction between barium hydroxide octahydrate, BaOH to 8H2O, and ammonium nitrate. And as you can see, we have some of each compound here. We have 25 grams of the barium hydroxide octahydrate, and we have 12.7 grams of the ammonium nitrate, which is a stoichiometric ratio for these two compounds. And we currently have a temperature here in the lab, according to our thermometer, of 21.5 degrees Celsius. Now, before we start the reaction, let's talk about this, because you might notice that I have my two reactants here in the solid state. This is a kind of unusual reaction in that this is a reaction between ionic compounds that will actually initiate in the solid state, unlike a lot of the precipitation reactions that we've talked about in class before. So, what we're going to do is we're going to mix these two solids, and then we're going to see what the effect on the temperature is from this endothermic process. So I'm going to pour the barium hydroxide octahydrate into the ammonium nitrate flask, and we will monitor the temperature. The reaction is going to look like this. Barium hydroxide octahydrate reacts with ammonium nitrate to make ammonia, which will be a gas in this reaction, water, and barium nitrate. So let's get started. So we will pour one reactant into the other one. And we'll need to try to mix this a bit. Do a little agitation to get the reaction going. And then we'll see what happens. Maybe we can use the thermometer to help us out a little bit. So if we look at the thermometer, what we'll see happening is the thermometer is showing the temperature appears to be dropping relatively quickly. If you'll look at the moment, the temperature has actually dropped below 0 degrees Celsius. Currently, and it's going still pretty rapidly, we're at -4 degrees C. Shake it up a little bit more. And we are currently at -7.7 and still going down. So what's going on in this reaction? Well, what's happening is this process overall is endothermic. So endothermic processes absorb energy from the surroundings. So what we have is, for this reaction to proceed, we have the energy being pulled in from the thermometer, from the flask, from the substances that have already reacted. And in fact, if we touch the outside of the flask, we'll feel it's quite cold. And the temperature inside, as you can see, has dropped to -10 degrees Celsius already. So well below the freezing point of water. Now, speaking of water, you might actually be able to see certainly some condensation forming on the outside of the flask. And it's actually frozen, so the flask is getting so cold that water vapor from the room is condensing and freezing on the outside of the flask. So this reaction is actually still going. -15.3 degrees C so far. Doesn't really show much sign of slowing down yet. -16, still going down. So as you can see, this reaction really pulls in energy from the outside. So that's what an endothermic reaction will do. Now, a few other things about this reaction that are interesting. It was a solid phase reaction. One of the products is ammonia. If you were here in the lab with me at the moment, you probably would want to plug your nose, because the smell of ammonia is steadily coming out of this flask. So if anybody were asleep in here, this would certainly wake them up. This reaction also produces water, which of course, is going to form in here. First is a liquid, and some of the places in the flask you can see some of this liquid water happening. If I stir it around now, you can certainly see the liquid forming. The reason it's a liquid, even though the temperature is currently about negative 16.6 degrees, is that we have an effect in here going on called the freezing point depression effect. Basically, the presence of other things like the barium nitrate in the water helps lower the freezing point of the water below 0 degrees. So the water on the outside of the flask freezes. The water on the inside of the flask, because of all the other junk in there, is still liquid. So what we see here is that an endothermic reaction pulls in energy from the surroundings and causes the temperature to go down. Now,